Given a matrix P with order is 3 by 3 and here X transpose denotes the transpose of the matrix X, then the number of 3 by 3 invertible matrices Q with integer entries such that Q inverse equal to Q transpose and PQ is equal to QP are how many we should find. Okay. First of all, let us take here Q is nothing but 3 by 3 invertible matrix no they give. So order 3 by 3, let's take it like this: A, B, C, D, E, F, G, H, I. Let us take a matrix Q with order is 3 by 3. Now conditions are what you see. First one they give here PQ is equal to QP, right? That means what you see. P matrix first we can take. P matrix means what? 2, 0, 0, 0, 2, 0, 0, 0, 3. Next Q matrix A, B, C, D, E, F, G, H, I. Right side Q into P, no? So Q matrix A, B, C, D, E, F, G, H, I. And here P matrix 2, 0, 0, 0, 2, 0, 0, 0, 3. Now multiply here, what happens? See. First row, first column, 2A we will get. First row, second column, 2B we will get. First row, third column, 2C. Similarly, second row, first column, we will get 0, 2D. Second row, second column means 2E, and here 2F will get. Third row, third column means 3G, 3H, 3I we will get it is equal to. Right side observe. First row, first column, 2A we will get. First row, second column, 2B we will get. First row, third column, 3C we will get, right? Similarly, second row, first column, 2D. Second row, second column, 2E we will get. Second row, third column is 3F we will get. Third row, first column, 2G. Third row, second column, 2H. Third row, third column, 3I we will get, right? Okay. Now these two matrices are equal, right? The corresponding elements compulsory should be equal. 2A for any value it will be satisfied. 2B equal to B, okay. 2C equal to 3C they give. 2C is equal to 3C means compulsory it is satisfied only for C is equal to 0. So C value compulsory should be 0. Next remaining also can check. 2F is equal to 3F is there, then F also must be 0. Next 3G is equal to 2G is there, G also must be 0. 3H is equal to 2H is there, H also must be 0. And remaining elements are exactly matched, right? So it will be satisfied for any integers. Next. Right, another condition C. Q inverse is equal to Q transpose give, right? So if you are multiplying either pre-multiplication or post-multiplication with Q, what happened here? Left side I only, right side Q into Q transpose possible or Q transpose into Q also possible. That means clearly it is what matrix? It's an orthogonal matrix. Q is an orthogonal matrix, right? Orthogonal matrix, right? Now we have the conditions here for orthogonal matrix. Sum of the squares of every element in any row or any column must be equal with 1, and sum of the product of corresponding elements of any two rows or any two columns is must be 0. Like that conditions we have, no, right? Here what is Q? First of all you see Q matrix is what? Updated matrix. ABC value 0 founded, D, E, F value 0 founded, G value 0, H value 0 and I value, right? Now conditions you can see here, all possible conditions. First one, sum of the squares of every element in every row, right? That means what? Here A square plus B square must be what? 1. A square plus B square is 1, and another condition D square plus C square is equal to 1 and I square is also 1, right? These are the all conditions, possible conditions. Next one more, what? Sum of the product of corresponding elements in any two rows or two columns is 0. So AD plus BE compulsory what now? 0 only. AD plus BE compulsory 0, right? So these are the all possible conditions, right? Now we can see here how many possibilities are there. Cases we can divide here actually. Case 1, suppose. See, if you take here A square plus B square is equal to 1 means compulsory A is suppose plus or minus 1 take means B is 0, or A 0 take means B is plus or minus 1, right? Suppose A if you are taking as 0, then B possible values are what now? Plus or minus 1, right? In that case, what happened here you see, in this case, see both mixing, right? These two. Now when you take A value 0, right, and b value is plus or minus 1, right? 0 plus 1 only will be, but it should be 0, right? Then compulsory e value must be what in this case? 0 only. E value compulsory 0. Okay, now e0 means what happened now? Compulsory d value either plus or minus 1 only now. These are the all possible values, right? For this equation and this equation and this equation, by combining these three equations we got it. This is one of the case, right? Now case 2, observe. Now suppose a is you are taking as plus or minus 1, a is plus or minus 1, then compulsory b value is what? 0 only, then only it will satisfy, right? Now in this cases, whenever a is plus or minus 1, b is 0, a plus or minus b is 0, right? So here we got some value, non-zero number, but it should become 0 when d is equal to 0 only. So d compulsory what now? 0. D compulsory 0. When d compulsory 0, e value is what now? Plus or minus 1 only possible. Okay, now we can see how many ways we can select. A we can select only in one way, and b can select in two ways, and e we can select in one way, and d we can select in two ways, right? So 1 into 2, 1 into 2, 2, 2 into 1, 2, 2 into 2, 4. So this is possible in 4 ways, and it is also possible in 4 ways. Total 8 ways we can select this. By combining this, 8 ways is possible, and I square is an individual option. I can be plus 1 or I can be minus 1. This is possible in 2 ways, right? So see, I can choose in plus or minus 1 anything, right? So in 2 ways possible. Okay, now we can see. So this is the this a b d e values we can select in 8 ways. Okay, overall combinations, a b d e combinations is 8 ways, and I can choose in 2 ways. So total 8 2s are multiplication rule only, we will use. So total number of Q matrices is how many? 8 into 2 will get it what? 16 matrices is possible, such that these are satisfying the given conditions. So our option is C, 16. Option C.